Okay, this video provides an overview for the signals from the cosmic dawn activity.
Hi, welcome back to U3D. Are you ready to embark on your next exciting research adventure? Press the play button to watch a brief video. This will hint at what this research task is about.
Okay, so this activity is the only activity that's a little bit different to the others, where the user will first do some tasks in the transporter room before putting their spacesuit on and selecting activity from the universe timelines. So let's have a look at that video that Kirsten mentioned by pressing the play button on the console.
The Square Kilometre Array, or SKA, will be the largest and most sensitive radio telescope on Earth. Two complementary radio telescopes located in Western Australia and South Africa will use different types of antenna to tune in radio frequencies. Low-frequency radio waves will be received in Australia by more than 131,000 Christmas tree-like antennas stretching over the horizon. Mid-frequency radio waves will be received in South Africa by around 200 dishes. Radio emissions from the furthest reaches of space reach Earth and are detected by the SKA telescopes. These are converted to digital signals and sent through fibre optic cables to supercomputers for processing into images and information for researchers. The amount of raw data coming from the telescopes will be amazing, nearly 1 terabyte per second. That's like downloading 10 ultra-high definition films every second. This data will help answer some big questions. Why is the expansion of the universe accelerating? What did the universe look like billions of years ago when the first galaxies formed? Is there life elsewhere in the universe? But the most exciting part about the SKA telescope, it will answer questions we haven't even thought of yet. To find out more about the SKA, its purpose, and who is helping bring this massive science project to life, visit www.ska.gov.au.
Radio astronomy extends our view further into the universe's history than optical telescopes. With their longer wavelength, radio waves can pass through many materials that would otherwise block or absorb other forms of electromagnetic radiation, such as visible light. You'll use the tools, the electromagnetic spectrum visor, the FM radio, and the scanner to see, hear, and measure a particular radio wave, a persistent signal that has been traveling through the universe for 12 billion years, and one that is of particular interest to Australian radio astronomers. You will do the first part of your research task here in the transporter room before teleporting to around 340 million years after the Big Bang to conduct part 2 of your research. There are a few steps to part 1, so I will talk you through them. So, let's get started. Put on your electromagnetic spectrum visor.
Okay, so the user is given the task to put on the electromagnetic spectrum visor, which is on the left of them on the bench, similar to the oldest light activity. So you pick it up by putting your hand over the top and pressing the side trigger. Then you wear them by placing up near your head, let go of the side trigger, and they'll snap on.
The visor has been pre-programmed to enable you to view radio waves. The waves you see all around you have been emitted by objects and events from the vast expanses of space, and these radio waves are important to radio astronomers. Take a look around. Teleport over to the U3D windows and look down to Earth. Come back to the console when you are done.
All right, so let's go have a look.
Now, pause the waves.
Okay, we're now asked to go pause the waves. Once we've had a look.
You need to single out a particular radio wave to start your research task. Use the FM radio to scan and tune in to the desired frequency or channel. You'll need to use your ears and your eyes. When you have found it, stop.
Right, so the user will see a whole lot of different colour radio waves around them in the transporter room. And then they come over to this radio, and then they'll actually try and scan in the desired frequency. So the sound will actually change, and you would have seen that the needle turns red. So the user can now try and aim for that red point. Oops, which can be a little bit tricky at times. There we go.
These red waves are obviously significant. On the monitor are 5 questions. To complete your research task, you must answer them with the information you collect.
Right.
Use your scanner to measure the wavelength of the red wave, crest to crest, or, if you prefer, trough to trough.
Right, so let's pick up the scanner and scan and measure the red wave. So we basically use the scanner and press the front trigger like we do when scanning in objects in order to select the points that we want to measure between.
Woohoo! Wow! 3 meters? That's quite a long wavelength.
Right, so at this point we need to take a snapshot of the wavelength information.
Woohoo! On your monitor, you will see 3 pieces of information about the red radio wave as we see it in the transporter room today. You'll need to go back in time to answer the questions. So put on your spacesuit and select the signals from cosmic dawn point on the universe timeline. I'll meet you there.
Right, so let's go put our spacesuit on. And then we stand on the timeline footpad and select activity. So this is the last point that's
Signals from the cosmic dawn.
down the bottom here.
Begin teleporting.
Welcome back to the epoch of reionization. The last time you were here, it was at astronomical size. This time, however, you are at atomic size and surrounded by neutral hydrogen atoms, lots and lots of them, as, after all, they make up around 75% of the baryonic matter in the universe at this time. Observe what's happening around you for a few seconds. What is being emitted by some of the atoms?
Right, so we can see photons are being
Now,
emitted.
pause the universe and select a hydrogen atom.
Alright, so we're going to now use the pause button on the console to pause the atoms, and then we can select or scan in a hydrogen.
Woohoo! Observe what's happening to the model on the analysis station. The electron is emitting a photon at a particular wavelength. Measure the wavelength.
As you can see, the electron got emitted and there's a wavelength left behind. So let's measure this wavelength and take a snapshot of its results.
Woohoo! Let's follow this wave as it travels through the universe. Your console will automatically teleport you to 3 different points in the universe's history where you can see this wave and measure its wavelength. Do you think it will change? Also, at each stop, you will pick up a photon emitted at 21 centimeters from the model of a neutral hydrogen atom. Ensure you take wavelength measurements of each emission line and check where you are on the universe timeline. I'll see you back at U3D when you are done.
Right.
Begin teleporting.
So you'll see the previous activity was at 340 million years. We're now at 1 billion years. We have a Kirsten note to look at, which is a spin flip transition. And we also have our task, of measuring the wavelengths. So we've only got one here, so let's pause that one now. Let's measure this wavelength.
Woohoo!
Let's take a snapshot of it.
Woohoo!
Then another wavelength will be emitted by a new hydrogen atom.
Begin teleporting.
Now we have two wavelengths from the two previous time periods. We actually see we're at 6 billion years after Big Bang. We've actually got a task, which is to measure these wavelengths. So let's pause them, measure each of the wavelengths,
Woohoo!
then take a snapshot.
Woohoo!
And another wavelength will be emitted from hydrogen at this time point. And then the user will be prompted to return back to the transporter room. So let's do that now.
Begin teleporting.
Welcome back to the present, 13.8 billion years after the Big Bang. You have 3 waves to measure. Do that now.
So as we can see, we've now got 3 waves from each of the time points, 340 million years, 1 billion and 6 billion years, that we need to take measurements of. So let's do that now, pressing the pause button, measuring the wavelength of each,
Woohoo!
and then taking a snapshot of their results.
Woohoo! So, you've seen a model of a hydrogen atom emit a radio wave at 21 centimeters 3 times, at 340 million years, 1 billion years, and 6 billion years after the Big Bang. You have observed changes in the wavelengths, taken measurements, and gathered data at each stop. When you return to Earth, use this information to address the research questions. It's time to take off your spacesuit and head back to Earth. Bye!
All right, so that concludes this activity where the user can return their spacesuit and return to Earth, as prompted by the icon. So let's do that now. Turning the spacesuit and now returning to Earth. And that's it.